For our lesson 11, we have the forces in space or the three-dimensional 3D. When a particle is in equilibrium, the vector sum of all the forces acting on it must be 0. Summation of F is equals to 0 and summation of M or moment is equals to 0. The three-dimensional analysis are summation of fx is equal to 0, summation of fy is equals to 0, and summation of fz is equals to 0. And the summation of force moment x is equals to 0. The summation of force moment y is equals to 0. And the summation of force moment z is equals to 0. The magnitude of force F in space are F is equals to square root of Fx squared plus Fx plus Fy squared plus Fz squared. The components of a force in space is Fy is equals to force cosine theta y, Fx is equals to F cosine theta x, and Fz is equals to F cosine theta z. For directional cosines, we have cosine theta x is equals to fx over f, cos theta y is equals to fy over f, cos theta z is equals to fz over f. So the proportion of components is f over distance is equals to fx over x is equals to fy over y and equals to fz over z. So here's our figure. As you can see, here's our y-axis, z-axis, and x-axis. And this is our fy, fz, and fx. So the formula of distance is equals to x square root of x squared plus y squared plus z squared. We have here a given problem that says the points B, C, and D of the cantilever framework shown are attached to a vertical wall. The 370 pounds to force is parallel to the z-axis. Compute the force in each member. So here's our figure. As you can see, our 370 pounds is parallel to our z-axis. So to solve our problem, we must first find the distances of each forces. So here's the measurement of each forces. Our A is 12 inches. 12 inches, and our Y, which is our B, is 0, or our C is 0, 0, 3. Then our C, which is our Z, is 0, 0, negative 3. Since it is from downwards, it is negative. And our D is 0, 7, this is our 7, 0, and our force is 370 pounds. And for our distance AB, we have the square root of 0 minus 12 squared, which is 0 minus our 12 squared, plus 0, 0, 0 minus 0 squared plus our 3 minus 0 squared. So the answer is 3 square root of 17 or 12.369. And for our distance AC, we have D 0 minus 12 squared and 0 minus 0 squared and negative 3 minus 0 squared. And the answer is equals to 3 over 17, 3 square root of 17 or 12.369. Since they have the same measurements, we come up with the same answer. So lastly, for our distance AB, we have D 0 minus 12 squared plus 7 minus 0 squared plus 0 minus 0 squared. And the answer is equals to square root of 193 or 13.892. Next is we have to determine the forces. For members X, Y, Z, we have AB, AC, AD, and force. For our member X and AB is negative 12 over 3 square root of 17. For Y is 0 over 3 square root of 17. And for Z is 3 over 3 square root of 17. And for our AC, we have negative 12 over 3 square root of 17. 0. For Y is 0 over 3 square root of 17. And for Z is negative 3 over 3 square root of 17. And for our AD, we have the member X is negative 12 over square root of 193. For Y is 7 over square root of 193. And for Z, we have 0 over square root of 193. And for our force, we have in the line of Z is negative 370 since our force is parallel to Z. To compute our forces, we have to use the proportion of components, which is the F over distance is equals to Fx over X is equals to Fy over X over Y, or and Fz is equals to Z. So for our Fx, we have the negative 12 over 3 over square root of 17. So the answer is, so for AB, we have the negative 762.775. And for our AC, we have also 762.775. And for our AD, we have AD is equals to 0.